Hi, everybody. My name is Arun, and I'm going to talk to you today about building scalable Slack bots with Go. Before I begin, just a show of hands, how many of you use Slack at work? Or how many of you interacted with a bot or know that you were interacting with a bot? Okay, fairly cool. Before I begin, just a little bit about myself. I'm the founder of Z Robot Labs. I've kind of been building Slack bots since last year, which is a fairly long time in the Slack bot world, I guess. I built one particular bot called Nestor, which you can kind of think of as a hosted Hubot. How many of you have Hubot in your Slack? Okay, just a few. So Hubot is kind of like your assistant that helps you with chat ops within your organization, and Nestor is Hubot as a service, I guess. It's done fairly well. It's been installed in over 1,300 Slack teams in just over a few months. And as part of building Nestor, I built an open source message broker for Slack bots called Relax, which is going to be the core of the talk today. So if you probably haven't heard, 2016 is the year of the bots, apparently. Slack has had a bot ecosystem for the last year or so. Newer platforms like Facebook and Kick have recently jumped onto the bandwagon. And Apple, just a couple of days ago, announced an iMessage API and a Siri API, which is kind of not exactly bots, but more around the concept of making your messaging experience richer with agents or humans kind of, enriching your communication with either your friends or your peers at work or whatever. So what exactly is a bot? So in the Hubot example, if for folks who have installed a Hubot within their team, the way you kind of do it is you install a service on Heroku or AWS or wherever that connects to your Slack team as a bot user. So it opens up a WebSocket connection to the Slack API and basically starts listening for messages or events that happen within your Slack team. And then it basically decides to take action on certain events. So if you say deploy latest version to Heroku, it would do all of that stuff. With a bot as a service, which is kind of like the new emerging trend, the challenges are slightly more different because you basically have to connect one bot user to multiple Slack teams that have added your bot to that team. So in the case of Nestor, like if your team installs Nestor, what that does is that you'd see a bot user called Nestor within your team, and that basically connects to the Slack API and relays all of those messages across. So the problem of kind of, as a Ruby developer, the problem of kind of doing that particular bit, the connecting to different Slack teams, is probably not a good idea. One, because you're kind of maintaining multiple, like thousands of concurrent connections to all of the different Slack teams that have installed your bot, which is both unwieldy and can get pretty expensive because of like how much memory Ruby takes, or replace Ruby with Python or Node.js or whatever. So having dabbled with Go in the past, this kind of seemed like a problem that Go could solve pretty quickly because basically you can spin up a Go routine for every team that signs up, connect to the WebSocket, and start relaying messages across. So as part of my design goals while building Nestor was that I wanted to kind of maintain the web application in Ruby or Rails, because there's a ton of great things that Ruby does really well in the web world. So like authentication and OAuth redirects and session management and all of that stuff, Ruby does really well. And what Go can do well is basically all of the plumbing behind connecting to Slack, relaying messages across. So what that means is that the architecture kind of looks like this, where you have your Rails application kind of handling all of that business logic, and it communicates with a message broker through a single the stream, whether that is a Redis queue or whatever, it doesn't matter. And that message broker kind of takes in all of the different events that come in from Slack and multiplexes that onto that single channel, which your web application can then consume. So this was how Relax was born, as you probably saw in the slide here. It multiplexes multiple events onto a single stream. It has a low memory footprint. So as a person who's bootstrapping this stuff, I don't want to spend too much money on infrastructure. So having to run this on a single Heroku dyno would be great. And I also wanted the ability to kind of run multiple instances of Relax without sacrificing things like message duplication, for example. So I should be able to run multiple instances of Relax and only get one copy of a single event down to the Rails app so that the Rails app can deal with it. So a little bit about the actual implementation itself. So in this particular example, whenever a new Slack team signs up to your service and instantiates a new instance of your bot within that team, the Rails application sends a message to Relax via Redis, which is basically just a JSON blob containing some information about what the team ID is, the token, and stuff like that. Relax then spins up a Go routine per team that signs up and basically connects to the Slack web real-time API and opens up a WebSocket and basically starts relaying information from the Slack real-time API back to the Rails app. So fairly simple. But the kind of interesting things are the Slack API does not implement the native WebSocket ping protocol, so you kind of have to be responsible about sending periodic pings to make sure that the connection is alive, and if it isn't, then reestablish the connection and so on. So Go routines and channels have worked great for this stuff because you can, without making your code base too complex, you can take care of complex network stuff. So the reason why I use Redis is twofold. One is Redis acts as both a communication bus as well as a data store, because there are two things that need to be achieved. One is the web application needs to send events to Relax and Relax back to the Rails app, and that happens via a Redis queue. But Relax also maintains state about each connection, so whether a connection is up or down, and even things like message deduplication happens with the help of Redis primitives such as etch-set-nx, if you're familiar with that. So the results were pretty great. I launched Nestor on both Hacker News and Product Hunt, and tons of teams signed up, and handling all of those connections was the thing that I didn't have to deal with at all because it just performed really well. It still handles it's not, the actual number of events isn't that high in the grand scheme of things, but not having to worry about that stuff without spending too much time or money investing in that infrastructure is pretty great. And it also allows me, as well as other developers using it, to kind of focus on building value within the bot itself and not having to worry about the scalability part of it. Some of the lessons that I kind of learned from open sourcing Relax and having it being used by other companies interested in building Slack bots is that people don't want to deal with running and sysadmining another process as part of their infrastructure. And the other interesting thing that people overlook, and this is something that I kind of stumbled upon too when I first started building for Slack, is that with bots you have to maintain persistent WebSocket connections, and this is something that web developers, when they first encounter it, are like, what? I thought this could be like a request response thing. So that is something that people take some time to get used to. And the final learning from building all of this stuff is that people don't know how to how well their bot is doing in terms of analytics and metrics and stuff like that. So as you probably imagined, I built Relax as a service and called it botmetrics. It's available today at getbotmetrics.com. So a few things that are interesting here is that like the whole concept of Relax has kind of been abstracted as a service. So you don't have to deal with managing a Redis cluster and all of that stuff. All of the events that come in from Slack you can receive all of those events as webhook events, basically. You get all of your metrics for free, and it's super simple to actually integrate your bot with botmetrics. If you go to github.com/botmetrics, there's Go, Ruby, and Node.js bindings for it right now. And yeah, this is kind of a screenshot of the types of stuff that you can get with botmetrics. Yeah, I guess that was a pretty short talk. Happy to answer any questions about Slack or bots or anything. Right, yeah, yeah, I should probably have mentioned that. Yeah, but basically, as you receive messages, your web application has all of that business logic to respond to those messages, and it would basically send a command back to Relax, and Relax would send the message back to Slack. Yeah. So the Relax API is public. You can read about it on the GitHub page. It doesn't need to be Ruby at all, just because I'm basically a Ruby developer and I built Rails applications. But there's a couple of people using Relax who've built their own kind of like Node.js bindings as well. All you need is a Redis client that picks up stuff from a queue and deserializes that the JSON back into an object. Yeah, that's a good question. So it is today specific to Slack. It probably won't expand to other services, mainly because most other bot frameworks, so Facebook and Kik, and I haven't looked at the iMessage stuff, but even Alexa, the Amazon stuff, all follow the webhook model. So you basically register a webhook, a URL on Facebook's side or Kik's side or Alexa's side, and it calls you back with an event. Slack is probably the only service today that has, and because I think they were one of the first ones, they still have the WebSocket thing. So if Slack had a webhook API, this probably doesn't need to exist. But yeah. Thank you.